Hi kids, this is lesson 94. Today we're going to be graphing systems of linear equations. And you have an objective today. You will be able to graph systems of linear inequalities after you're done with today. So why don't you write the highlighted stuff in your notebook, day 94, the title, graphing systems of linear inequalities. And then also I will be able to graph systems of linear inequalities. Okay, so write that down. Alright, you should have written all that down. We're going to move on here. Again, if you need to pause the video at any time, please do. So, here are the steps. Pause the video right now to write down the steps, and then I'll show you how to do numbers 1 and 2. Alright, so here we go. So numbers 1 and 2. So I want to show you how this works. So yesterday we talked about how to graph one of these. So today we're going to be graphing two of them. So for example, we have number 1. We have two different lines. We have this first one and we have the second one. So a good strategy to do is just graph these one at a time. So like on number 1, if I look closely at this, I could just cover up the second equation. Right, and I can see, oh cool, it's in the right form. We have y is greater than, right, greater than negative x plus 2. So, and the number in front of x is negative 1. So it's like saying our slope is negative 1 over 1. And our y-intercept is 2. Okay, so what we're going to do first is go to our y-intercept of 2. And we're going to plot some points for slope. Run negative 1, run 1, down negative 1, run 1, and so forth across my graph paper. And I'm getting a nice straight line, right? And then I look at my inequality, right? Remember yesterday? You see how it says greater than? It doesn't say equal to, so I want a dotted or dashed line. So you see how I already have a dashed line? I mean, I could add a little bit more dashes to it to make it look more dashed. But we're noticing that this line will not be included in our solutions. It won't make my equation true. So I'll put some arrows at the end. And then I look at my inequality sign and it says greater than. So that means I'm going to have to shade above. So I'm going to shade above here carefully. And what this is saying is anything in this area would make this first equation true. But that's not the only equation we had. We also had the second equation, right? Remember this one? So we want to make sure we include that. So now we're going to do the second equation. So I'm going to focus on the second one. I notice that it says y is greater than negative 6, x minus 3. So my slope here on the second one is m is equal to negative 6 over 1. And then my y-intercept is equal to negative 3. So I'm going to go to negative 3, and I'm going to go down 6, 3, 4, oh no, I don't have enough room, so I'm going to have to go the opposite way. I know that my line's going to be negative, so it's going to go this way. So I'm going to go up 6, 1, 2, 3, 4, 5, 6, and over 1. There should be a point here, and it looks like that's a shared point. And I could try to go up farther, but I can't. Ran out of graph paper, but that's okay. Then I notice my inequality says greater than. It doesn't include equal to, so I'm going to have a dashed line again, or dotted line. So I'll start making a dotted line between these 2 points. That kind of looks a little messy. I'm going to try that again. And this one is, when I look at the inequality, it says greater than again. So we want to shade above it. So above it, think of you walking above the mountain. So this is a very steep mountainside. So above it would be on this right side. So I'm going to just shade right to the right of it. And I'll use a different color so we could see the contrast here. Let's use blue, okay? And what I'm noticing here is that I have three regions. We have this region right here that's yellow only. We have this region down here only blue, and then we also have this region over here that is like blue and yellow. So it should be green, right? Kind of looks green. So anything in this region here would make these equations true. So if I pick any point here in this area that goes on forever out in this direction, in any of these directions, I would be able to find a solution that would make this system have logical sense. Okay? Or I could try to pick these other ones. Like if I pick anything here, this would not make my equations true. If I pick the yellow one, it would only make my first equation true and not my second one. And if I pick the blue section, it would only make my second equation true and not the first one. We don't want that. We want to pick a solution, any place that's a solution for all of them, which would be, again, this area. And just a quick review, remember that we cannot use any of the dotted lines as solutions. So even though they're here, they're boundaries, but we cannot use them as solutions. Anyways, that's how you do number one. Now to number two. Number two, again, I'll go a little bit more quickly. We have two equations. The first one has a slope of -5, so I'm going to go to -5. And I notice this is going by 2, so it's got a 2, 4, 6, 8, right? So I'm going to go to -5, which is actually right here. And my slope is 1 over 2, so it's going to be up 1 over 1, 2. There's going to be a point here, right? And it's kind of confusing because of the boxes, but we are going 1 unit and over 2. And I keep doing that across my paper. And I'm going to go the opposite direction too, so I could get a nice straight line. And I notice that it says equal to and less than or equal to, so now I could draw a nice straight line on this one. And when I look at the inequality, it's less than or equal to, so I'll start off with my yellow highlighter. It's less than, so I'm going to go underneath and shade underneath it, okay? And I'm shading with my pencil if I was doing this on a paper. Next one, it says positive 12 is my y-intercept. So I'm going to go up 2, 4, 6, 8, 10, 12, all the way up here, right? Slope is -2 over 1, right? We can make this a fraction, so it's going to go down 2, so down 2 over 1. So we have to be careful with counting the boxes. Down 2 over 1, right? Yeah, or we could keep going, sorry, not or. We'll just keep going in this direction, down 2, 1, 2 over 1, and down 2 over 1. We keep doing this down our whole paper. And then we look at our inequality for the second one, and you notice it has the equal sign right in it. So we want to make sure this is a solid line as well. And it also says greater than or equal to, so I'm going to shade above it because I could walk on the mountain above it. I'll use a different color. Let's use, blue didn't look too good last time. Let's use something that's a little bit more transparent, I guess, or gives us a little bit more contrast. So I'll use this light green. Let's see if this works okay. No, that doesn't work. Let's use a darker green. Okay. So now we have our inequalities done. So anything that's shaded in the yellow, this whole yellow region would make this first equation true, and anything that's shaded in the green region would make the second equation true, right? Any points and any of those lines, but we are looking for a point that would make both systems true. So we want to pick the area that is shaded with both colors, which is this area right here. Any point in this area and the adjacent lines, since they are included as solid lines, we could use them as points that would make this system of equations true. Okay, so just building off from yesterday, this is definitely a procedural lesson, so learning how to do this. So pause the video here, write these down if you haven't, and then I'm going to give you an opportunity to try a couple on your own. Alright, let's move on here. So what I'd like you to do, pause the video here, and then I'm going to show you the answers on how to do number on these two, okay? Please pause, let's practice a little bit, and then check your work. If you get it right, then you should feel pretty good about yourself for tomorrow. If not, please come with questions, okay, and I'll be glad to help you out, alright? So let's pause the video, try these out. Alright, so you should have worked these out. So here we go. I'm going to show you how to do the first and second one. I'm just going to press play here so you can see what's going on. So the first one, you can see you got the first equation is shaded in that direction. Second one, you have a solid line here for the first line. And then we have a dotted line for the second, right? And then it's shaded again less than. This one's interesting because it is shaded to the right or below. So just a couple points here. Just remember the yellow region, the yellow area is where it satisfies the first equation. The green area is what satisfies the second equation. If you have an overlapping area, these points satisfy both equations. So, and then anything on this particular line right here would satisfy both equations as well. Not on this dotted line. Okay? So on the second one here, you notice how everything that's in the yellow region would satisfy this first equation. Everything in this green and yellow region would satisfy, well, it would definitely satisfy the second one, but it would also satisfy both of them because they're both less than. It's kind of an interesting problem. So, and we have two parallel lines. If you notice, they're parallel, they're straight, they'll never cross because they have the same slope. Alright, so that concludes the lesson. We'll talk about this more tomorrow, alright? Thank you.